Welcome to Mastering Solutions. This is another calculate the image position and height question, and we don't need to draw a ray diagram for these ones. You could, if you wanted to practice, it's really good to do that. I can almost guarantee you'll have a ray diagram question on your test. And so in this one, we're just going to do the math calculations, and we'll use the thin lens equation to first calculate the position. So we know that 1 over f is equal to the power of a lens, and that's also equal to 1 over the image distance plus 1 over the object distance. We're trying to solve for this, so if we minus over 1 over s, that will give us 1 over the image distance is equal to 1 over the focal length. And this, since we have a converging lens, the focal length will be positive, and we're going to minus 1 over the object distance. So 1 over s prime is equal to 1 over the focal length, which we said is a positive 0.2 meters. And we're going to minus, this does need to be in meters to give us the correct answer, because a diopter is an inverse meter. So if it's not in SI units for that, it won't work correctly. And then we're going to minus the object distance, and we said it's 15 centimeters in front of a converging lens. So the object is closer than the focal length. So that means with a converging lens that we're going to have a virtual image, and it will be upright, and it'll be on the same side of the lens. And we'll explain that here in just a second. So 1 over the 0.15 meters, and this is positive since the object is upstream of the lens. 1 divided by 0.2 minus 1 divided by 0.15 gives us a negative 1.67 diopters. And we want that in meters. So if we take the inverse of a diopter, that gives us a negative 0.6 meters or a negative 60 centimeters. So that's our answer for the image distance. And now we need to calculate the image height. And so magnification equation is what we're going to be doing for this. That's equal to h prime over h, and that's also equal to negative s prime over s. And so we're going to set these two next to each other because we want to isolate this, and we have all three of these now. So if we multiply over h, those will cancel, and now we have h prime is equal to h times a negative image distance over object distance. So the image height is equal to the object height, which we said was 2 centimeters. So 2 times 10 to the negative 2 meters. And we're multiplying that by a negative, and s prime was negative, so that's negative 60 centimeters, so 10 to the negative 2 meters. And remember, this negative comes from the equation. This one comes from the answer, so don't forget those. It is important. When we plug this into the calculator, obviously you see that we can just treat this as a positive 60 centimeters because the two negatives will cancel each other. Now, the object distance is, let's see, 15 centimeters in front. So we have 15 times 10 to the negative 2 meters. So we have 2 times 10 to the negative 2, and that's multiplied by negative times a negative, gives us a positive 60 centimeters, and then divided by 15 times 10 to the negative 2. So that gives us 0.08. So we have 1, 2. So that is 8 centimeters for the height of our image. So with a sign convention, it's important because now the answer tells us more information. So with the image distance, this negative tells us that we have a virtual image, meaning it's on the same side of the lens as the object. So if we drew the lens here, here's the lens, here's the object, and then it's, let's see, inside the focal length. So the focal length's here. The image is going to be over here like this. And so the 8 centimeters, because this is positive, tells us that the image is upright. So we have a virtual and an upright image. And so these are all of our answers. We have the image distance or the image position. We have the image height, and it's a virtual upright image, of course.